Hey guys, welcome back to Houdini Houdono, the simulation edition, and this is a 10-part mini tutorial series that introduces you to the basic simulation techniques in Houdini. This is Ronald speaking, and in this last episode of this series, I'm going to show you how to make clothing. It's something that me and my studio is really into these days. So what you see on screen now should be something like a coat or a cardigan of a person walking. So the thing about making clothing in Houdini, it's basically using the Vellum simulation techniques that we have seen in the previous episodes, and the only difference is we need to kind of have an understanding of pattern making. So what it actually is, if I may load up my browser. So what it basically is there's this whole other in-depth knowledge on how to cut fabric and stitch them together in order to make clothing. So this is a whole entire deep dive into another profession. So we are not going to dive all the way into that. I'm just going to show you the basics of how to make some clothing. And yeah, let's get down to it. Just as a quick run through, all we need to do is to load in a geometry like this. I got this from Mixamo. You can see that it works in a box cycle. And then just use the curve tool. It gets better in Houdini 19 because it now features a curve tool where we are able to then basically template our geometry and draw some sort of a pattern, and we just mirror them all over front back like this, and we use the Vellum Drape node to stitch our pieces of cloth together to make our clothing. And then we will clean up all the attributes that help us to make this clothing and redefine our cloth, create some constraints so that it attaches to the body, run the simulation and ensure that it's loopable, and then we will end up with this. So it sounds pretty straightforward, and it is, just that there are some little kinks to look out for when creating this setup. Okay, so let's get started with a new file. Go to File, New. Okay, so here we are in Houdini. Let's go through a mock setup first to explain to you how the Vellum Drape works. Okay, so I'll create a geometry node and rename it Setup. Uncheck the display flag and dive inside. So here I am in my setup node, and in order to understand the Vellum Drape, I'm just going to make a very simple example. So if I hover over my viewport and press spacebar 3, hop over to the front view and locate the origin like this. If I drop down the curve node and with it selected, press enter in my viewport and just draw 4 straight lines like this. 1, press enter. 2, press enter. 3, press enter. And 4, press enter. Careful not to let it snap to each other. Let me draw that one again. I'll explain why this is important in a second. So when this is done, I will drop down a resample node to make sure that each of these lines have enough points, something like this. And next, I'm going to drop down a fuse node. So with this fuse node, I'm actually going to slowly increment my fusing threshold such that the corners of these points merge together. And next, I'm going to drop down planar patch from curves. This is not enough resolution, so I'm going to change my interior edge length to 0.05 and resample the curves. But importantly, I need to check these seam groups. So these seam groups takes the node name, so I can call this my cloth. And if we middle mouse this, we can see it's cloth seam 0 to seam 3. And if we select the node, hover over the viewport, press S, make sure we are on point selection and go to select and choose geometry groups. You will notice that we can hover over here and select each of these edges. So this is why it's important to draw each of the straight lines separately. And don't worry about the accuracy of this because we can always come into the curve node, hover over the viewport, press enter. That allows us to jump into the curve tool, press F for edit mode, and we can select the point we want and just move it along like this, right? So don't have to worry about accuracy. At the point, it's always adjustable. And with that, we can see that it all still works the same. So what is the point of being able to select the point groups as such? It's because we can then use the Vellum system to stitch these pieces of cloth together, right? So how do we do that? First, we can call this the front, and we can alt drag this to the side and call this the back. Append a transform node for the back and just move this backwards a little bit, and then we can attempt to merge these two together. Next, as usual in the past Vellum tutorials, you will see that we can quickly configure this as a cloth and drop down a Vellum solver, check on the ground position, and we can solve this. So because it was intersecting with the ground, it pops up like this. We want a way to weld these two pieces of cloth together. This is the original Vellum solver, but we don't have to use this one. There's this special variant of this solver called Vellum Drape, which allows us to make our clothing and stitch pieces of cloth together. So with the Vellum Drape node selected, under Draping, additional seams, we can actually click on this source group here, choose the front targets in this anti-clockwise manner or clockwise if you choose to. Go to the first frame so that we are operating on the first frame, and choose the target group to be in the same selection order, A, B, C, D. And if we press enter, you can see that I've chosen the front seam 0 to seam 3 and back seam 0 to seam 3. And it has drawn this imaginary line in between, and these are the weld constraints. So if we were to run this Vellum Drape now, it sticks together like a pillow, right? So this is how you can quickly model a pillow. And you will notice that on frame 11, it starts to actually stitch together because under weld properties here, there's a welding frame delay 10. If I change this to 0, on the first frame, it will attempt to snap together. And we get the pillow instantly. So this is only to stitch clothing together. It's not the vellum solver for our cloth simulation. So you can think of this as a modeling tool for our clothing. Then after you're done with modeling the clothing, you can then use the vellum solver for simulating the clothing. And you will notice that also the back view or the front view has a reversed face. We can drop down a reverse node here, and then they will all be front facing. So this system is entirely procedural because we can now go to this front and back over here and change this to higher resolution. And you will notice that because it's Houdini, the point groups are there, this is a higher resolution simulation now. And just to give you a glimpse into what I mean by this is modeling and then we use the Vellum solver for simulation, is that we can say this frame 15 is a good frame. We can say freeze frame at 15 on the drape. And then we can then clean out all the attributes here, except the weld attribute. So everything except weld. Then we can drop down a Vellum configure struts, soft body. We can also move this pillow up above the ground a little bit. And then just use the Vellum solver at the end of this. And check on the ground position. I'll go to visualize and turn off the ground collision preview visualization and run the solve, and we get this. So the first drape node was entirely meant to model the pillow, which I have frozen over here with this convenient checkbox. We can also cache it. And next is the actual solver, which does our simulation. And in this case, the struts is a little bit not stiff enough, so I'm going to increase this to 1000, and our pillow should behave like a pillow. So now if we set up the Vellum configure struts correctly, we will be able to get a pillow that behaves like this. Okay, so the last thing I want to point out is that the planar patch from curves actually defaults to having some UVs. It's just that it calls it material UV over here. So this is not very much aligned with the rest of Houdini. So I'm not sure why this is the case. Maybe some of you who know can leave a comment below. But what I generally tend to do is to then just drop down a quick point wrangle to say that V at UV equals to V at material UV. So in that case, we will be able to see that the Houdini's default UV previewer, which is this checkbox over here, will be able to pick up the UVs like this. And if we press spacebar 5, we will be able to see the UVs generated like this. It is not laid out properly, so we can then use UV layout and just append it over here, and we can see that Houdini automatically helps us do the layout of these UVs, and we can then use these UVs for shading and whatnot. So this is something that we have to take note when we do our clothing. Right, so this is the basics of how to draw pieces of cloth and how to stitch them together. Now let's apply it. It's not super exciting, but I think this is the basic theory of it. Let's get to drawing some clothing patterns and putting it on our character. I'm just gonna call this setup pillow and make another geonode, call this setup, and this will be our main setup. So I have here a character from mixamo.com. It's a motion capture library with some nice preset characters. This is a nicely stylized character with some textures. So let's get a head start as we learn how to make clothing patterns, right? Generally, to draw a clothing pattern, we want this character to be in a static pose instead of moving. So let's drop down a time shift, and this time shift node, if we control shift click here, which is to break all channels and leave it at frame 1, you will notice that it stays on frame 1. Okay, so this is where we can just drop down null to say that this is a static pose and that this is the animated pose, just to make things clear for us. Next, I can template this static, and then we can drop down a curve node now, look at our curve node, put the display flag on it, hover over our viewport and press enter. That's where we can start drawing our curves, but we don't want to draw this in 3D space, so spacebar 3 brings us to our front view and we can start drawing our curves. Remember to draw each line separately. So I'll start here. I will only draw the right side of the character like this. First line, second line, third line for the sleeve, my fourth line, and my fifth line over here. And I'll finish this off like that. Next, I will draw a long sleeve along this character. So here to here, I'll just make it slightly baggier. From here to here, and finally from here click in the middle and drag, and here. Okay, then I'm going to extend this piece by clicking here to here and drag a very similar length. Just make it super wide. Click from here to here, enter, and finally from here to here. So that's basically it, and then I'm now going to press F and just make sure that these points be closer together. So what you can do is just to select the points and middle mouse them to the desired position like this. You don't have to do it to 100% accuracy because we have the fuse node to help us later. So it will be nice if the Houdini side effects team will allow us to find some way in the UI that allows us to draw from point to point without them snapping. That'll be quite nice. If the length is different, the stitching might face some difficulty, so I'll just make sure that they look very similar like this. And now I will drop down the resample, and we can see it's too coarse here, so drop it down to 0.02, and I can now drop down the fuse and increase my fuse amount very marginally until all the corners are fused together like this. And I'm going to drop down planar patch from curves. So this character has been prepared to world scale, where it's 1.3 meters tall, so it's not very tall. But to do all this clothing simulation, it's best to do to a certain scale that we're used to. If we are working at a scale where the character is 1 point something meters tall, we can safely say that 0.02 is a good resolution to start. Okay, we can always increase the resolution like this, and it will always remember it's a procedural software. Okay, so let's check resample curves so that it's a bit more even at the sides too. And remember to check on these seam groups, which allows us to store each of these edges as its own group, just that it takes this node name, so I'll call this right front, RTFR for short, and I'll call this top, right front top. So why did I call this right front top is because I'm going to append a mirror node and uncheck keep original so that I get only the left side, and I'm going to drop down a group rename so that I can cheat this by renaming all my right to left, RT star to LF star. So I can see now that there's a left front top, and over here there's a right front top. So with these two selected, I can merge them together like this. So if I middle mouse here, I get a bunch of seams over here, and they should be at the front of the character. So they are not now at the front of the character. I can drop down a transform node and just move them along the z-axis so that sits in front of the character. And now I'm just going to drop down another mirror. So I'm just using the ones that I've done before. And instead of mirroring on the x-axis, I'm going to mirror on the z-axis over here, 0 to -1. So it's at the back now. I have a distance parameter here that I can adjust so that it's tight closer to the back of the character. And in my renaming, I want to rename what was front star to BK for back star over here. FR star to BK star. So what happens is I now have, it says that it's complaining that it cannot find anything that's FR star. And this works because I wrote RT at the front. So I only need a star after RT. But I left FR in the middle, so I need to make star FR star and star BK star. Right, so no more complaints, and it's renamed correctly. Now I can merge these two together like this. So I have my top done. Now all I need to do is to hang on. I just did not notice that the entire bottom half of my cardigan is missing. So let's find out what happened. Maybe it's the resample or the fuse didn't get something, but when we create the planar patch, it has disappeared. Let's find out why that is the case. So it's probably because this is too far apart. So I'm going to go to my curve node, look at it, press enter, and just move this down over here. Right? So the patches are created correctly, and I can continue my work. So back down here, this is basically my top. I'm just going to drop down Vellum configure cloth, and it should then play back like a piece of cloth. Oh no. I drop down Vellum configure cloth, leave everything as its default, and drop down Vellum Drape. Okay, so with the Vellum Drape selected, check Weld additional seams, and while we can choose the source group and the target group one by one by clicking this select tool, make sure it's point select and choose geometry groups. You can choose this edge over here, press enter. That commits to my selection over here. Then I can click on this one and click the back edge here and press enter. and then it draws this. We will create many of these and it can look very messy. So there's the possibility to combine some of the selections together, and I'll show you how you do that. So when I click on this to refresh my selection, to reselect what would be in my source group, I can actually start here and just go anti-clockwise over here, holding down Shift. Okay, you will notice that this has been fused together like this. So this is also not normal. And I think it's because on our fuse node, we left this default fuse snapped points checked. So I would like to uncheck that such that they put these 2 points on top of each other, but they don't fuse them together. So they are still individual lines, and that will help us make a clear separation. So back to the Vellum Drape. Click this. For my front piece, let me click in an anti-clockwise fashion. This. So it appears that I drew this as one curve, that's why. So I'm going to delete this point and draw another curve here. So press G, click here and click here, press enter, press F, and I'm just going to move this over. Okay, so that was the culprit. Let's continue the Vellum Drape. So now finally, I'm just going to click this, the sides that are meant to be welded from the front to the back, right? So I'm just going to go anti-clockwise and select everything that's on the front panel that I want to weld to the back corresponding panel. This, and this. So I'm going to press enter now, and I'm going to select this and do the same. And you can see it's welded them all together. So if I run my simulation now, you will notice that we are getting somewhere, but it is not colliding with the character. So we gotta fit this static body into the Vellum Drape over here. And let's see what that does for us. Okay, that's not too bad. We are missing some of the welds, and also this has gone through the character. Right, so let's fix those two. This back has been mirrored, but it's off position after the mirroring. So in that case, let me just ensure that when I mirror this, this goes farther back, like this. Okay, so then I keep everything procedural. Also, when I drew my curves, I ensured that there is a good clearance from the front piece to the back piece. So in that case, on my Vellum Drape node under Weld Properties, I can turn off the frame delay. So on the first frame, I basically want it to snap from the front piece to the back piece and let the solver resolve it. So let's see what that does. So it's all right, except over here, there's not enough give over here such that it intersects. And also we forget some welds. So let's just go back over here and fix this curve here, this point here. I'm just gonna press F, select these two, and get a little bit more material here so that they don't get caught up in the geometry there. And just jump down back to the Vellum Drape. Run the simulation again. Okay, so we're missing some Vellum welds over here, so let's address those. Go back to first frame. Under weld seams, we can add additional ones. So it's a little bit tricky because we cannot do that shortcut anymore when it's from the front panel to the front panel. So we just have to be patient about this. Go to select geometry groups, click on this, press enter, select this and click on the next one and press enter. You will notice that this is reversed, so we can check this reverse box here and it will be connected correctly. Add another weld seam slot. Click on this, check reverse. Click on this, check reverse. Maybe we should fast forward this process in the edit. Click on this, and check reverse. And finally, I do want these two seams at the back to be connected to each other, and these two also. Instead of pressing plus, which adds a slot at the bottom, I can actually press this green button here and it adds a slot at the top. So I don't have to scroll up and down. So I'll select this group to merge with this group, and this point group to merge with this point group. So you can see that it's quite difficult to select here. The same selection from my source to target, so let me fix that. So that's correct. And alright, also my sleeves, right? So let me press this. I need 4 of them. From this guy to this guy. We can see that it's reversed. So I'll check all the reverse boxes right after. From this guy to this guy. From this guy to this guy. And finally from this guy to this guy. So They are all reversed, so I'm going to check all the reverse boxes here, and we're done. So if we run the sim now, there we have it. So right at about frame 5, we're actually good with the solve. So I'm just going to freeze this at frame 15, something like this. And we're done with the modeling part of it. Now it's the time to clean up all the existing attributes and uncheck, remove degenerate primitives, because sometimes we can lose important information if we leave this checked. And next we can drop down a Vellum configure cloth to reconfigure our cloth, and drop down a Vellum solver. And this time we will input our animated geometry as our collision geometry. And then now we can turn on the ground plane, increase our substeps a little bit, and drop our constraint iterations to 20. And sometimes the visualization at the back can be distracting, so I'm just gonna select the solver, go to visualize and turn off show collision geometry, and just change my template flag from the static one to the animated one, and run the playback. And you see that everything falls as if the weld is not there. And it's true, it's not there, because on the clean node we have removed all attributes. So we do want to remove all simulation attributes except for one, which we can use this caret here, except weld. And if we run the simulation again, it should then work, right? So we can get this cloth to look even softer by going to the Vellum cloth properties here and changing the bend stiffness to 2 steps lower, from 3 zeros to 5 zeros. And we will see some additional wrinkles. Of course, in order to get a very high-res simulation, we will generally increase the resolution over here at the cost of simulation time. So just for this tutorial, I'm just going to keep it quite manageable. And when we go for our final sim, well, we can increase the resolution. Okay, so now you notice that it falls off the shoulders, so we don't want that. So what we can do is we can go to our animated null here, select, say, this edge loop here, or this one. Just go to the edge selection mode, double click on the edge loop, press tab, type group, press enter. We will create a group, and we can call this group neck. So why did we create this group for? Over here, we can drop a custom Vellum constraint. And this Vellum constraint, we can choose attach to geometry. And what this does is it takes the input geometry and attempts to connect it entirely. You can see all the constraints that are drawn to the collision geometry, and this is not what we want. We specifically want to target specific edge group, which we just defined. So let's choose edge over here as the target geometry and choose neck. So once again, it connects the entire piece of cloth to the neck, right? This is also not what we want. So our source geometry group, we can choose points and select some of the neighboring point groups, like this neckline over here. It's kind of difficult to select it because if I'm trying to select this edge over here, there is this stream default source, if you can see in this dialog box here. This is generated by the Vellum Drape node, which makes it difficult for me to select my specific point groups at the edges now. So under the clean node, I can say remove that stream group. I will just be lazy and type star, stream star. And now in my constraint selection, I have removed that group, so I shouldn't be so distracting now to select some of the neighboring point groups. So this one, this, and this. And we can see that it has made this attached to geometry constraint. By default, the stretch constraint is quite strong. It's 1 times 10 to the power of 10. So this makes it like a permanent sticking feature. We can lower this to 1. So let's hope that it keeps it quite fluid. So when it's 1, it's opening up like this. As long as it doesn't fall off, I think it's a good number to follow. Okay, and let's just check this animated group over here to see, template this to see how well this works. And if we press spacebar 2 or spacebar 3, we will see that at the start, I think the cloth penetrates through the floor. Oh no, it doesn't, because I went to the solver and remembered to check the ground position. So remember to do this. So it generally works, but what doesn't work so well for me is that the sleeve here at the start is fine, but once it collides with the body, this happens. So this could be the result of not enough simulation constraints, or the P scale, the per point scale of this incoming geometry doesn't really match up with our Vellum cloth configuration's P scale here. What I mean is, if I drop down a sphere and leave it as a primitive, and I choose a copy to points node and copy a primitive onto every of the Vellum configure cloth here. This tells me what Houdini has automatically computed to be the per point collision for internal collisions and external collisions. But we cannot say that that is the same for our incoming geometry here because it's huge. So what we have to do is then to do an attribute copy of a very specific attribute that has been defined. We want the output to go into the Vellum attach, but we do want to copy the p-scale attribute from this Vellum cloth node. So we put this as the reference stream, and over here, what I want to copy is the p-scale. So when we do this, we will notice that the p-scale is now matching the cloth like this versus when it was before, like when it was huge like this. So this is good for our collisions. And we can come back here. We don't need these nodes anymore. It was just to explain this concept to you, to steal the p-scale from what Houdini automatically calculates as a good p-scale for the simulation based on the density of the geometry. So let's get back to looking at our simulation. Okay, I do know that in this walk cycle is from frame 27 to frame 84. So let's just watch it and see if it loops in that sense. Okay, the cloth is a little bit long, so it's causing the character to kick it, and that's not so nice. And also, it doesn't really loop perfectly because just the nature of simulation, it doesn't loop. So in general, it's a little bit too long. So let's get back to this curve over here. And you might be wondering why is it so long even though we have only drawn up to here. This is because I'm cheating it. I'm using a lower resolution simulation, which allows the cloth to stretch a little bit more than usual. But the trade-off is I can simulate faster at the cost of accuracy. So I will do this compensation by moving this cloth a little bit higher without increasing my simulation substeps. So with that, I have to go to my Vellum Drape here and reset the simulation for it to recompute up to frame 15 and just run my solver again. So this arm still collides within itself here. And in order to solve that, I'm just going to attempt to increase my substeps to 5 and see if that solves the problem. Okay, if that doesn't solve the problem, then I suspect that in my animated geometry, the geometry actually rubs into each other exactly like this. So you can see all kinds of cloth simulation software demos, they prepare their geometries to have no intersection. So in this case, when it came from Mixamo, it's already like this. So I will have to do some animation adjustment. And if I do that, then there wouldn't be any collision issues anymore. And I do not have to increase my substeps to this amount. But what I do get with this amount is it doesn't stretch as much. So we can see that it keeps the accuracy of the length. The results are pretty good. So I'm just going to keep it at 5 here. If we want more wrinkles and folds, all we got to do is to go here to the planar patch from curves and change the interior edge length to say 0.01. And what you will see in the drape node, instead of the resolution looking like this coarse, if we press reset, let it sim, we will see a much higher resolution geometry like this. And when the resolution of the geometry is higher, the simulation time will go higher, but you will get a much more detailed cloth simulation. So let's run this simulation for a little bit. So you can see now that we are getting some nice folds over here, which wasn't possible with the previous resolution, and some nice folds over here too. Okay, so I'm just gonna cache this, and it should take maybe 2 or 3 minutes. So drop down a file cache node, rename my file cache node to cardigan, and just press save to disk. But I might not want to save all these simulation attributes here, so another clean node for me. Importantly, I don't want to keep my UVs. So actually, on this clean node, I realized I threw away my UVs, so don't do that. Let's keep UVs. And also, in the pillow example, I explained that we gotta transfer the UVs from material UV to UV, right? We didn't do it here, so let's do that now. Just drop down a point wrangle to say that V at UV equals to V at material UV, so it copies it over to what is default to be Houdini's way of picking up UVs, as you can see like this. And on my UV view, like this, it's nice, but it's not in the 0 to 1 grid. So let's drop down a UV layout, drop it here, and it will put it into 0 to 1 grid like this. And we can do a UV transform to make sure that everything is probably facing outwards. It makes a bit more sense, so I'm just going to rotate this 90 degrees. When we're done with this, we can clean away the material UV attribute by dropping down clean and remove the material UV so that we only have one attribute that defines the UV, so that it doesn't get confused. On my Vellum Drape, let me press reset and see if I get all the UVs correct. Okay, so this is good. The UVs are stable. And now on my clean node, just do a last check that I don't remove degenerate primitives, and I remove all attributes except a weld and UV. And this is just from before where I removed the stream group. I can leave it there and let's see. So press I here and just click on more, and they all seem okay. Probably the only one I want to remove is my Vellum object 1, which just describes the whole geometry. So I'm just gonna star Vellum star. So it removes that one primitive group, and that saves some memory. Insignificant, but it's something. And let's run the cache now. So the cache is done, and let's look at what we have. It's stretching at the front, but if we go from 27 to 84, it should look fine. So it's still slightly stretchy, and in order to solve that, we can increase the Vellum solver iterations, or I think I lowered the constraint iterations a little bit too much. We can revert this back to 100 and run the simulation again, and we should get a better result, right? But I think it's okay for the lesson purposes, so let's continue. Right after this, we can drop down the Vellum post process. And right now, if I check extrude by thickness, it has no thickness because it doesn't have a p-scale attribute. So it's our chance to fix our simulation. So let me go back to first frame, change these constraint iterations back to 100, and then I will then go to my clean node here and ensure that we do not throw away our p-scale attribute. Let's remember this is weld, UVs, and p-scale, right? Okay, we are good to run this simulation again. In fact, I'm just gonna run it from frame 27 to frame 84 to save some memory. Okay, so the cache is done. Let's look at our Vellum post process, and you will notice that it gives it a thickness based on the simulation p-scale, and we can cheat this to make it look like a thinner piece of cloth by changing this to 0.5. And also you will notice that this looks a bit jaggy here. That's because we threw away some of the normal attributes, but we can easily regenerate them by dropping down a normal node here and just change it to point normals, and you can see that it's okay. If we use the Vellum post process node now and uncheck apply welds, you will see that we can have the option to keep some of these seams together. This makes it look like a convincing piece of clothing. And then over here, we can optionally do a subdivision, which can be heavy on our viewport. And you will notice that it splits open over here because in our simulation, this is separate pieces of cloth. And if we run a subdivision like this, it opens up like that. In order to counter this, what we can do is to ensure that there's this concept of adding a crease weight attribute, and be it Redshift's subdivision on render time or the subdivision in Houdini, it will respect the crease weight attribute and ensure that the edges over here will retain its sharpness. So how do we do that? We can drop down a crease node, and if we look at it now, it basically adds a crease weight vertex attribute onto the entire geometry. I can actually not subdivide over here and append the crease after, because my Vellum post process node is the one that generates this thickness over here, and it also gives me 3 primitive groups. One defines the front face, one defines the sides where the front and the back meets, and one defines the back face. So it's called extrude back, front, and side. If I were to add a crease node, I can choose it to apply onto all 3 of them. And what happens is if I subdivide now, after the post process, it keeps this edge looking sharp, right? So before it would be the case that it opens up like that, and after it keeps its weight like this. We can also lower our crease attribute to 0.5, so we get something in the middle, or 0.75 if you want to create some illusion of a hole over there, but I think we keep it as 1. And you will notice that this looks a bit jaggy over here. We can of course redefine all our normals once more as point normals, and just drop down our attribute blur. Blur the end attribute and blur it by 5 iterations. Then we can get something looking smooth like this. Okay, so one other thing is, notice this vellum post process here. I told you guys that we could uncheck apply welds, and to give this look of all the seams of the clothing like this. It looks nice, but sometimes we maybe want to remove, say, this one. So in order to do that, we should leave the apply welds on so that it runs on all the seams except for some that we don't want it to run. So how do we do that? What we can do is to write a custom attribute. So drop down a point wrangle here and just say that at weld equals to -1, and it should be an integer. I at weld equals to -1, and we only want this. So if we apply this onto the entire group, you will see that our vellum post process node, even though we have checked apply welds, it's unable to apply a weld because we have defined that for every point, the weld integer attribute is -1. So basically, this attribute allows us to bypass the welding. So we can isolate this to specific groups. And once again, we have this very annoying group selection here called stream default source. So let's drop down a group delete, and let's delete stream, anything that has got to do with stream. So now we can select the point groups that we want to keep. With all of them selected, I can then deselect, say, this one and this one. So if I press enter now and check my vellum post process, you will see that we preserve all the seams except for those two that I deselected. I hope that makes sense, and you can selectively choose what would be nice for your simulation, which means when you draw your patterns, you don't have to try to warp it around your character, try to do some tubular thing and try to warp it. You can draw as many patterns as you want to weld them up, and after the simulation, you can decide which seams you want to show and which seams you don't want to show. We are done with our simulation. I will show you guys briefly how to render this with some of the textures that came from Mixamo, and then we will be done. Drop down a null node, null, and call this out cardigan, and drop down another null node for this animated geometry here, call this out character, and jump outside, create two new geometry nodes. One is called cardigan and the other is called character. And inside cardigan, drop down an object merge and click on this to reference to the setup node and choose out cardigan. And we'll do the same for character. Object merge, let's choose character, out character, and we have these two geometries in our world space here. I should create a camera first, so drop down a camera node, just call this render cam. Look through the camera like this, click on this padlock button so that if we navigate our viewport, we are actually moving this camera. And my camera resolution, I want this to be 1920 by 1080 and choose my focal length to be 120 and just frame it in the center like this. If I scrub now, it's a little bit slow because it's doing all the attribute blurring on my normals. Actually, if I go to my setup node and temporarily move my file cache right to my cardigan here, it will be a lot lighter and I can scrub. So this is a bit more encouraging to work. Then next, what I want to do is to drop down a grid, and basically to make my backgrounds, I'm just going to uncheck this padlock. And for this grid, I'm just going to make a UV unwrap in case I want to give it some texture. Alt drag it, press enter. I can rotate this 90 degrees and move back on this axis. Alt drag it again, rotate this another 90 degrees and zero this out and move this back along this axis. Right, so I can get this character moving along in space. All this looks like it's walking on the spot, so maybe I want to cheat this by not having this wall at all, but have this very close to the character. But it's a perpendicular wall, so we can complete the illusion as if it's walking forward, right? Or rather, not break the illusion, right? We leave it ambiguous as if we cannot tell if it's walking on the spot or walking forward. That does mean that we cannot put any textures on the wall, but that's fine. Let me drop down a light dome and choose the HDRI we have been using throughout this series, Desert. And I'm just going to uncheck the enable in viewport and just going to kick off the render now. If I didn't define my Redshift render properties to use this camera, it created a new one. Let me just stop the render, press Ctrl 1 for my object context, press Ctrl 2 for my material context, switch to out node and press Ctrl 3 for my render output context. And with the Redshift node selected, just point to my render camera and under IPR, just check these 3 live update checkboxes, right? So our life will be easier and choose all the necessary settings to render the frame range and whatnot. So I have a preset here, I'm just going to use that one. And under my material context, I'm just going to make 3 materials. One is for the cloth, so Redshift material builder. This is for the cardigan. This one is for the character, and the last one is for the backgrounds. So with my scene view selected, press 2 on my node view, just drag and drop cardigan to cardigan, character to character, backgrounds to backgrounds, and also this one. So if I kick off my render now, it's rendering the whole scene and it's rendering the full resolution. Just gonna go to fixed scaling and change this to 50%, so it renders only half the resolution. Stop my render, kick off the render. So it should go a little bit faster. I'm going to now delete this cam 1 and rotate my light dome to a favorable position, to something like maybe this, where I can see my character. And I don't want reflections in my background, so I'm just gonna go to my background object and make it super rough, so maybe 0.5, give it enough samples here. And for my character, the thing about Houdini is when you look at your character node and you can see the shop material path, this is one where it conflicts with your material assignment, so I will drop down the attribute delete and specifically delete the shop material path attribute. So with that, if I kick off my render, it will actually start to respect my character material here. If I change it to red, it should then change to red. So I'll drop down a RS texture node and hunt for the file texture that comes with this Mixamo model. Just use the diffuse will do, and then I'll just plug it into the diffuse color, kick off the render, and I should see my character's color over here. Right, so we give it a nice cardigan. So let's shade the cardigan now. Just go to the material context by pressing 2, which we set up just now. Let me just hide the character for a moment so you can pay attention to the cardigan. I will drop down the diffuse weight to 0, and you will notice that this is very shiny. It doesn't look very much like cloth. And even if we blur the reflection over here to 0.5, it still looks like leathery and plasticky. This is because for fabric type materials, how the light actually interacts with the surface is actually the furs on the cloth and not the actual front facing surface of the cloth. Light is catching all the little tiny furs, which gives it this peach fuzz quality to the shading. So in order to achieve that, if I just turn off my reflection for now, it gets 100% dark. The Uber material on Redshift has this sheen attribute. If we turn it up to 1 and just drop the roughness to 0.1, you notice that it mimics the feeling of a furry cloth like this, right? So let's give it enough samples like 512, maybe increase the roughness to 0.15, and you will see how this differs with the normal reflection module. I can drop this sheen down to 0.75, and let me just keep this image and show you the comparison with the normal reflection module. This is the normal reflection module where when the light hits it, it's basically reflecting the light into the camera, and then this is what you see, right? It looks very leathery, but the sheen attribute actually captures the light tangentially, so it gives us this feeling of a furry surface, which is typical of cloth. Now we can turn off the reflection, or we can use a little bit of both and just do it to taste. We can actually mimic red velvet by choosing our diffuse color to this dark red, and of course turn up our diffuse. I think it can be darker than this, and you can see this sheen attribute already gives us the feeling of the furriness, and we can choose our sheen to be a magenta color, which is slightly desaturated, and you can see that it looks like a kind of like a velvet material. And how do we complete this look is we give it a cloth texture, of which I will drop down a RS texture node and look for displacement, and I'll just plug it into displacement and drop down a RS displacement node and plug it in between, and just lower the scale to 0.01. If not, it will explode because it's a world unit. And I will choose my color space to be auto. Go back to the OBJ context, and for our cardigan, we gotta go to a Redshift OBJ tab and go to tessellation and enable tessellation and enable displacement. And we can use adaptive subdivision, but sometimes it doesn't work so well because we need it uniformly subdivided for a nice even fabric. So I recommend that we turn the adaptive subdivision off and just put a maximum subdivisions of say 2 or 3 and change our minimum edge length to 0, so it forces it to be 3 subdivisions or 2 for a start. And let's kick off the render. Maybe before the displacement, I just want to check that the texture is of a good size, so let's click playback while we plug it to surface. So this size is not really working. I will copy this parameter here and paste it on the right side, paste relative reference, so that I will only need to change this side, and I'll change this to 0.1, and I can see a cloth texture over here which is large, so maybe 0.25, slightly better, maybe 0.2. Yeah, so I think 0.2 is okay, and I'm just gonna stop my render and change this back to 100% scale. Kick off the render. I can see how this tiles. You can see that there are some seams over here, but they will look fine because it's exactly where our pieces of cloth joins, right? So this seam can even make it more believable. So I'm just going to change my scale back to 0.5. Yeah, so I think this is fine. I'll just plug it into displacement and plug my color back. And I get something like this. So this displacement is a little bit strong, so I'm just going to drop it to 0.005. And there we have it. A very nice cloth material. I will now show my character, and I think my character by default is too shiny, looking like porcelain. So let me go to the character here and just go to material and change my roughness to 0.45 and give it enough samples. Say 512 will do. The IOR I can drop it to 1.4. So this is kind of like a cheat because all the textures, I cannot really define the material properties from this texture because they are all baked into one object. But this front facing thing is looking kind of strange. So maybe I'll lower my reflection light just a little bit and maybe blur this out more. Okay, and this is the thin geometry. One last thing I want to talk about is if we want to really mimic the thinness on this material, there's this backlight translucency here. Let me keep this image here. If I increase this to 1 and just plug a yellow color, just 0.1, you can see it mimics the feeling of light passing through. Usually we will choose something of a very similar hue, but I think it's not very convincing because this is just a flat piece of plane. I don't know if you remember, on our setup here, I momentarily plugged the cache of the single piece of cloth right into our output. So let's fix that by using what we originally intended to do after attribute blur, and let's just look at the effect of this one. Right, so it has thickness now. You can see that at the edges it catches the light, and we can play with this backlight now by pushing it up to 1.25. And if we just choose a very similar hue like this red here and push it up to 1 and make it desaturated. If we pass a strong light through, you can see over here, let me just keep this image now. Before it was like this, and after we are able to mimic some light passing through a thin surface. So this is the backlight translucency. It's probably easier if I hide the character. So let me just show you that and do a before and after. Before it looks like this, and after it looks like this. So before, no light passes through the cloth at all. It's a very thick piece of cloth. And if we allow light to pass through, it looks something like this. So before, after. So this might have altered the hue quite a little bit. So we can be very sparing with the saturation and very sparing with how much we want to push through. So I think something like this is nice and stylized. I'm just gonna show my character now. You can see it allows light to pass through. Just take care not to overdo it. I think it's looking a little bit transparent now, so let me just dial that back a little bit. Okay, next is background. We can choose a color that complements this whole purple hue. If we are very proud of the cloth that we have done, we can optionally lower the saturation of our diffuse texture, color correct, so that the cloth simulation stands out more. Or something really saturated like this might be funny. It's kind of nice. Actually, for the fun of it, I'm just going to try to put the cardigan's displacement onto the character to see if we can make them all feel like cloth. So this character is also made of cloth. Yeah, even the skin is made of cloth. That's kind of interesting. And I think I'm just going to exaggerate that effect quite a bit. Maybe even for the cardigan. So 0.01, and for our character 0.01. I think I want the cardigan to be a bit louder. So let's see how I can do that. And since the character is so stylized, I'm just going to try to lower the texture size a little bit, back to 0.25. Also for the character, 0.25. So that we can see a large cloth patterns. And perhaps just for the cardigan, let's go 0.125. Okay, I hope you guys enjoyed this tutorial on how to make clothing in Houdini. The good thing about simulating your clothing in Houdini is that you can then do all your custom visual effects work. If you need to make it slightly rigid here, and over time, based on some custom attributes, it becomes soft, you can all do that using the usual Houdini tools. And if you have some soft body interaction, you want some bouncing balls on the cloth and all those kinds of things, basically you can combine the entirety of the Vellum toolset to affect the clothing simulation. So that's the power that you have in Houdini. Otherwise, if you just want to do some clothing and just simulate the clothing, I highly recommend you check out Marvelous Designer. So anyway, this is the last episode of Houdini Houdono. I hope you enjoyed this series. It takes some time to do, and for those who have been following along, thank you for your patience. This series started out projected to be a beginner series. Over time, it has evolved into something quite intermediate. I wanted to keep this like 15 minutes to 20 minutes, but based on the feedback I got along the way on the YouTube comments, it appears that you guys like this longer form content and all the information that I provide in the video, so I've changed the course of the presentation at least along the way. Otherwise, it still covers very in-depth, very step-by-step, and I think if you are just stepping out of the beginner phase of Houdini and just want to understand simulation better, I think you can check out this entire series from episode 1 to episode 10, where I cover particles, volume simulation, cloth simulation, hair simulation, fur simulation, and a bunch of Vellum stuff. And I think I'll be doing another tutorial series that is closely related to Maya, because Maya is a very good software for character workflows, and if you want to create characters, Maya is the software for you because it can handle some destructive modeling quite well. And also Blender is a good software, C4D is a good software. I just happen to be using Maya for the longest time, so I'm looking forward to that course. I'm planning that course now, so I'll see you on this channel for that. As always, if you have feedback for this series or if you want another season of Houdini Houdono, please let me know. If you need it to be more advanced, or maybe I can do a new season that's working off of this current season and bring it into the advanced level, or show you some production setups that we use on actual projects, please let me know in the comments. I also want to do a heads-up display tutorial and a Redshift in Houdini tutorial. I'll prioritize the Maya one first. There's a huge demand for like heads-up display stuff, which is really nice to do in Houdini. You can let me know and I'll try to fit that in. So if you like to follow more of my work or some of the tips and tricks that I post, I'm the most active on Instagram. So let me just load up my page. Instagram handle is @Ronald_Fong, and you can see that as I progress along my creative journey, I document some of the stuff over here, so you can check that out. Some of the production setups and learnings that we gather on our projects over the years at Masonry Studios, I'll make them into posts like this, which you can follow along. These are some insights that we have gained over the years on how to create effective setups, how to make sure that our visuals stand out strongly. So this is work that's ongoing. We want to give more information to fellow creatives out there like yourself. It's just nice to see everyone sharing. We also want to give our 2 cents back to the community. And also there are some tools that I release over time, like this quick switch tool, which you can download on my Gumroad. Yeah, so if you just want to keep in touch or just want to ask me some questions about Houdini Houdono, please come to Instagram and just DM me. I will respond. And for those who want the annotated version of this file, I will get to it right after this. So just DM me clothing. I will drop you the link to this annotated file and you can watch this video and follow along. And if there's anything that you missed, you can check that file. If you found with some cool clothing, please don't forget to tag me. I would love to see what you create following along this tutorial. I wish you have a good weekend, and once again, this is Ronald speaking. Thank you and bye bye.